As you settle in, we may have a seating thing that we're... Can you hear? You can't hear. Back there, you can't hear. Well, come closer. Yeah. Get on up here. We'll try to turn it up. You want to turn it up just a little bit? See if we can blow anybody's eardrums out. Check, 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 check. Hey! Any better? All right. Sweet. Okay. Whew. Okay. This is by far the biggest turnout we've ever had here tonight. So I'm curious, just by show of hands, who we have as first-timers in the house tonight. Okay. Awesome. Fantastic. I thought there'd be a little more, but fantastic. Thanks for coming out, everybody. Ah, man. This is good stuff. Okay. So first order of business I wanted to touch on before I go any further. The hashtags for this evening are Mozilla and Dev Roadshow. So should you feel like you want to tweet anything, either preface it or finish it with this business. So just want to get that out of the way. So for anybody who is new here tonight, my name is Mike Bates, and I'm the founder of the SGF Web Devs. And tonight is a super special event that we were thankful to be able to get the Mozilla Developer Roadshow here tonight as they're traveling the world. And we'll talk more about the individuals here in just a moment that are here this evening. But before I do that, generally I'll get up here and go on and on for a couple minutes about upcoming events. And there are quite a few things going on right now, and a couple things in specific that I wanted to take a moment to highlight. And I won't go into detail. Generally, I'll have everyone step up, but I think I'm just going to have one person talk about the event tonight. But Tech It Out is a huge technology event that happens every October. It's fantastic. It's growing every year. I mean, it was sold out last year. It's going to be sold out again this year. It's a really good event. So Tech It Out is October 26th. Google it. You'll find it. Go to it. This is one I wanted to dedicate a little bit more time to, and I tried tracking down Greg earlier. Is Greg? All right. Maybe he was told that he was going to be put on the spot here. So, big event going on, and I don't want to spoil it by doing it any injustices. So I'm going to turn it over to Greg here.
Awesome. So yeah, Hack for Good. It's going to be happening on November 3rd through the 5th. Super, super excited. We're basically getting all the tech talent in Springfield together to be able to do a lot of good. We're going to be partnering up and building an app for iPoor Life, their life strengths program, and what that is basically helping kids that are aging out of the foster system to be able to gain social capital. For a lot of them, it means just getting their birth certificate, learning how to drive or get a driver's license, and learning just how to be a part of society, because a lot of them, they're not bad people. They just need a second chance. They need people like you guys and gals to come alongside of them and help them out. So right now, we are partnering with them to build them an app, and it's going to do some amazing things. If you have not signed up yet, go to Hack4Good SGF. It's hack, the number 4, goodsgf.com. Register. We're still looking for participants. There's going to be high school students there. And we're also looking for corporate sponsors. If that's something you or your company want to get involved with, it's an amazing, amazing thing. So go sign up.
Greg also runs a pretty sweet podcast, Dawn of the Devs. So be sure to check that out. Okay. Just a quick recap of some of the other events going on. The VR open house. So a lot of you had a chance to play around on Self Interactive's VR rig over there. They do this the first Friday of every month. I think 10 to 6. Or something. Yeah, cool. Good enough. 10 to 6. Awesome. Here. So they've got an office here. So if you want to know more about it, come play around with us more. Check that out. And then we've got the Northwest Arkansas Women in Tech Conference on the 16th. Python group, per usual, meeting up here on the 17th. New one, the Atlassian user group, is meeting on the 19th. Just about every one of these you can find on meetup.com, by the way. So if you're interested in Atlassian technologies, check that out. They're meeting somewhere on the south side. MATA, of course, standing event on the 19th, and the .NET Users Group on the 24th, and the Thunder Plains Conference. Hands up if you've been to Thunder Plains. Oh, yeah, there we go. There we go. Awesome. Tom, myself, and a few others went to this conference a couple years ago in Oklahoma City, and it was absolutely amazing. It was actually one of the first events that I started kind of getting in contact with the developer community in OKC in Tulsa. And it was just a really, really good event. They keep stepping it up every year, so be sure to check that. Is it sold out yet? Good. All right. Thunderplains.com. This is a question mark. Conf. All right. Google it. You'll find it. Oh, geez. Yeah. Oh, my gosh. Conflict. Next slide. I just wanted to. I just mentioned some of the Oklahoma developer community people, and I just want to take a moment to highlight it. First of all, express our appreciation that these guys even came down here. These guys are all from Tulsa. You'll see them all here in a little bit. You've all kind of heard me, or most of you at least have heard me kind of gush about the communities that they have going on in these areas. I can't stress enough like how inspiring it is to see these developer communities popping up, and especially in the Midwest area, right? This is something that we don't necessarily have enough of around here. And I always kind of, whenever I'm telling the story about how this group got started, it always kind of starts with, what they're doing in Oklahoma. So I just wanted to highlight that. I really love these guys, and I really appreciate you guys coming down tonight. And we also love our sponsors. So, of course, Mozilla tonight hooked us up with a ton of stuff. The food that you enjoyed was brought to you by them, and everything else in here tonight was brought to you by Eagle Speak with the booth over there. If you guys did not make it over to that booth, they are giving away some pretty sweet swag tonight. They got some mugs, got some hoodies. To get that swag, you go to eaglespeak.net/Mozilla. Sign up or sign in if you already have an account. And as we transition speakers tonight, we're going to give away some stuff each time. So I'll kind of reiterate this each time. So if you want any of that mug or hoodie action, sign up at eaglespeak.net/Mozilla. And mothers for donating the brew. Shauna's back there, been slinging it all night long. Yeah. So thank you so much to all the sponsors. And I cannot go without thanking the E Factory. They donated this space. They donate the space for us every month to meet in. Just the best place to be. So please put your hands together for the E Factory. Somebody's pointing at me back. I don't know what. What? Oh, yeah, thanks, Kendra. Kendra, my little sister, she checked all of you guys in tonight. She's fantastic. Okay, so I got like 2 things left here, I promise. What's going on with the Web Devs group for the rest of the year? So generally in December, we try and do something kind of different and fun, and it's kind of failed the past 2 years. We try and do like a movie night or something, and I think like a grand total of 3 showed up. So that was cool. So we're doing something different this year, and maybe this one will catch on. Who knows? So for November and December meetings, we're going to do some hack nights. Many of you will remember that I've talked about this for quite a long time. I feel like the past year I've said, we've got a mobile app coming, and it never happens because, life happens. So I figured this would be a fun time maybe to utilize the skills of the group at large. And the idea here is for the November night, we'll get together. It'll extend well beyond, the normal time. It'll probably go, 1, 2 in the morning kind of thing. We'll have extra beer, extra pizza. This will be kind of a planning session. We'll get into groups and kind of plan out how we would build this app. And the app's pretty simple. It's mostly a check-in kind of thing. You can see the topics that are coming up. So instead of signing the stupid sheet every time and passing it around, we'll all have the app and just sign in that way. And then when we give away prizes, it'll alert your phone so we don't have to do the random number thing. that's pretty much the gist of it. There's a couple more things. But so November will be kind of more of a planning night, assembling teams. I'll set up all the server infrastructure and give access to the teams that need it. And then throughout that month, we can kind of on our own time, hack away on some things, and then kind of come back in December and have another fun hack night, and hopefully finish it all off. The plan is to use some hybrid technologies so we can all use our web skills, so we're not building, a native app. That would be quite a bit of work. And then launch this thing, hopefully by the end of the year. So it'll be pretty simple and hopefully pretty fun. But that's pretty much all I had. I am going to turn it over to Greg Tatum now, who's going to kick off this Mozilla hotness. And we'll need just a second to change computers, so hang tight.
All right, well, Mike pretty much covered everything about the introduction, so I'm going to repeat everything he said about Mozilla and everything else. So this is part of the Mozilla Developer Roadshow, where we've gone, we have them all over the world, and we've been making different stops in different places. So some of the Tulsa folks have been going around to some of the more regional areas and kind of talking about what makes the web work and how Mozilla is involved with that. So Mozilla, in case you don't know what it is, we're a non-profit and we're champions of the internet, helping to keep it healthy, open, and accessible to all. Okay, so what does that mean? Oh wait, my slides are out of order. I'll tell you what that means in just one second when I get my slides correct. For the Developer Roadshow, we have a code of conduct for everywhere we go. There's a lot of words right there. But if the TLDR is friendly, safe, and welcoming environment for all. And if anyone has any concerns, reach out to one of the Mozillians and we'll chat. So Mozilla makes the browser Firefox. So that's kind of the obvious place where most people know about Mozilla. But there is much more to what Mozilla does than just that. Mozilla helps fight for the open internet and making sure that it's accessible. And what that means is, well, for one thing, we do have the browser. We're the only independent browser that's not tied to some kind of greater service trying to sell you apps on the App Store or feed you ads on Google. So as an independent browser, we can advocate for things that other companies might not want to, and we help champion for different technologies. So what that means is that we might build a documentation website for Mozilla Developer Network, which I hope all the web devs out there are using. It's great. Or it's championing new languages, or even doing policy and advocating for different legislation that helps everyone have a better experience on the internet and making sure that it is open and accessible for everyone. So that said, yes, the browser is kind of like the central thing that Mozilla kind of represents and stands for. And looking at what's coming up, here very shortly, I wish I could tell you the exact date, but we have been reinventing how some of the core part of Firefox works. And that is called Project Firefox Quantum. So this is according to the speedometer metrics, Firefox is twice as fast as this time last year. So if you haven't used Firefox in a while, I encourage you to give it another try because it's new, fast, and fierce according to our marketing, which I believe them. And with that, we have a new logo. So my shirt is now legacy and out of date. But our stickers back there are the new stickers. And so I'm really excited about the new logo, especially the slightly unofficial one. And so with that, we'll move on to talks. We're going to do 3 different talks, each 15 minutes. And after that, we'll have a Q&A. And if you ask a question, we've got Firefox plushies that we will throw at you and hopefully not hit the person that's sitting next to you. It just says Firefox, so I think it's the same typography. And yeah, Luke, you ready? Oh, shoot. I did not update your slide. We'll let them use their imagination. All right.
That one. Thank you, sir. My password is all dots. So I'm going to talk about how to run your code on the dark web. This is the first time I've ever given this talk, and this is a highly censored version of it. Well, not censored. Maybe censored, whatever. So this could be a train wreck. All aboard. Choo-choo. So my name's Luke. I'm a web developer by trade and training. I work on privacy and security technology at Firefox. I click through slides really fast. I'm groove coder on all the things, and these slides are already up on Speaker Deck. So if you want to go look at them right now, you can do that. Okay, how to run your code on the dark web in 15 minutes. So how to run the code on the dark web and why you should. Everyone has this dark, scary connotation. Oh my gosh, the dark web, right? But actually, when you get into it, the dark web is not like magical, mysterious dark. It's actually just web technology. So there's kittens and rainbows there as well as all of the bad stuff. So this is really about how to write your code for the dark web and why you should. And when we talk about the dark web, we're talking about the Tor browser. Tor is a browser. Tor is mostly Firefox. It's patched Firefox with the Onion router. Why is Tor patched Firefox with the Onion router, you might ask, or I might make you think, because I put a slide up there. So the EFF has a great guide on sort of how Tor and HTTPS together can protect your privacy online. So I'm going to rip off their guide and a lot of their images. So you think about the internet, the clear net, as we will call it now. You think about IP and DNS and HTTP threats. The ones we always kind of think about are hackers in the middle. And then some of the ones we know about, don't think about a lot. ISPs are snooping on their customers' activity. Governments in other countries, never our country, are censoring sites. Corporations are scanning web logs to see competitors, or criminals are scanning web logs to see law enforcement or something like that. So this is a very big guide that we will jump into. But essentially what you have is in the top left here, you've got a user, a happy user. They have a happy face. Everyone else in this slide is very angry except for the sysadmins. They have this sort of like neutral, plastic, dead-eyed, what has the world done to my career look going on with them. Sorry, Josh. So yeah, in the top right, you've got this user who's getting ready to go to site.com, and this really just kind of shows you all of the hops that are involved with a user getting to site.com. So they've got a Wi-Fi network. There could be a hacker sitting on that one. There's their internet service provider. There could be agencies that are watching their internet service provider. There's the internet service provider of the site they're trying to reach, and then there's the site itself, right? So each one of these little buckets has, again, this is the train wreck. So it has a site.com, like the user and password they might send, some other data, and the location. In this case, the location is their IP address. So when you see location here, it just means IP address. So HTTPS, we all know it, we all love it, we all use it, or you should by the end of this talk, hopefully. It protects the user password and the data from these intermediaries. So if we dive into this diagram and see how this looks, now this hacker can only see the site.com that is being visited and the IP address that is visiting it, right? So same with your internet service provider. They can see where you're coming from and where you're going to. All of the agencies in between can see that. The site's internet service provider can see that. And the site itself, because they're on the other end of that HTTPS connection, you're actually sending them this data, right? So really, HTTPS only takes care of one of these things, right? ISPs can still snoop on their customers' online activity, governments can censor sites, all this bad stuff can happen, right? So how do we protect this location and the destination from these intermediaries? Now we're at Tor. Tor has patched Firefox with the Onion router. What is the Onion router besides the acronym for Tor? So this is a diagram about how Tor works. In the top left, you have Alice, always the hero of every security talk. And Bob is in the bottom right, has a server, has a website. So Alice is going to try to connect to Bob's server using Tor in a way that will actually protect her from the intermediaries knowing what she's doing. The first thing that Alice does is she gets a list of all of the Tor nodes from a directory server. The server is public. It just tells you all of the Tor nodes that are out there in the world. Alice's client picks 3 of these nodes at random, and she creates what's called a circuit in Tor. A circuit is a sequence of 3 node hops in the Tor network. And we'll dig into that in a second. But what you need to know is that by doing this, Tor actually hides each of these pieces of data independently from different actors. So if you dive into it now, the hacker can see her IP address and that she's using Tor and nothing else. Her ISP sees the same thing. And now we have these 3 Tor relay nodes. The first one is called the guard node or the entry node, and it can see where she's coming from. It cannot see where she's going to. The middle one can see nothing. This is the effect. This is why there are 3 nodes. This middle node is the magic node that strips these 2 pieces of data away from each other. The exit node, the last node, can see where she's going to and that she's using Tor. And then the site.com can see that she was using Tor and can see the data that she sent. Tor does this, right? This is how Tor protects against all of these things. So if you want to write your code for Tor, realize that Tor routes through 3 networks. You need to optimize for latency, but you should be doing this anyway, right? Latency is kind of known to be the #1 slowdown of all websites or web apps. You should be optimizing for this more than bandwidth anyway. You can do that by minimizing the number of requests. You can help the browser with resource hints, use good caching. This is an interesting one. You can make CDN. Some CDNs, you can actually activate them to work with Tor exit nodes, which will actually help. But if you want to dive into those, you need to come to Thunderplanes, because this talk is going to be, the expanded version will be at Thunderplanes, and we'll dig into all of that stuff. Yay, your site is faster for Tor users, but now all of your Tor users are hacked. So if you noticed, at this point, the Tor exit node here can see the user password and the data. How does that happen? So let's go back to how Tor works. Remember, Alice picks 3 nodes, and she builds a circuit using 3 nodes and is going to go to this site, right? The way that Tor encryption works is you have Alice's original data is here in the middle. What Alice does is she takes the exit node's public key and encrypts that data with the exit node. Then she encrypts all of that with the middle node, and then she encrypts all of that with the client node, or with the entry node, right? So this is actually how the nodes are prevented from seeing what data is in each other, but it also means that the exit node can see whatever original data she sent in the pipe, because the exit node gets to decrypt her original traffic, right? So if you've got a nice little hacker sitting in an exit node, and this has happened, they can see user password and data, right? And everybody else down the chain can see that too. And the exit node threats are the same as any other man-in-the-middle threat. You can snoop on all of that. You can hook browsers. You can put binaries in there, all that bad stuff. Anyone Mr. Robot fans out there? Okay, so I'm not giving anything away. This is like literally the 3rd minute of the entire show, where he says, the onion routing protocol is not as anonymous as you think. Whoever controls the exit nodes is the one who controls the traffic, which makes me the one in control. This is exactly what he's talking about when he says that. There's a lot of realistic stuff in Mr. Robot. So what you need is you need Tor and HTTPS. This is going to protect the location, the destination, the user password, and the data from all of the intermediaries. So if we go, oh my God, you should be using HTTPS already. On my speaker deck, there's also the slide, or the talk that I used to give at this roadshow about security errors. Spoiler alert, Let's Encrypt and Certbot is basically, you need to use that. When you do that, your traffic outside of the exit node will be protected by HTTPS. Everyone going down the line doesn't see anything. So yeah, your code is faster and it's more secure for Tor users, but now your code is broken in Tor. So remember that Tor is patched Firefox. And specifically, it's patched Firefox extended support release. So extended support release If you were to go into Tor and say about Tor, it will tell you that it's Tor 702 and it's based on Mozilla Firefox 52, right? So Firefox maintains an extended support release, like a lot of other packages, for people who don't want to ride the update train like every 6 weeks, and especially a lot of downstream vendors like Tor that don't want to have to update all of their stuff every 6 weeks, right? Firefox maintains this, so right now it's 52. Early in 2018, it will be 59, which means it will get all of the nice Firefox quantum goodness, which I'm really excited about. So what you need to do is you need to make sure your code works in the Firefox ESR, right? You should actually make sure your code works in all browsers. That's just better for everyone. And the first step to this is to go download ESR. So you can get it from the site that Josh makes sure you can get it from, which is mozilla.org. And then whenever you have it, you can use the tools that Greg builds, which are the Firefox dev tools, to debug your code in Firefox ESR. You want to come to ThunderPlanes if you want to learn more about debugging that. But some of your code is still going to be broken in Tor. So Tor is actually a patched version of Firefox ESR. So Tor has this concept of adversary models guiding their implementations of protections against those. And this is, if you go into the Tor design spec, it's like really lengthy. You know, you need to have a couple beers and be watching boring soccer to get through it all, which is how I did it. But this guides the patches that they put on top of Firefox. So one example of this is they know that people can be fingerprinted, right? So the implementation to protect against device fingerprinting is called cross-origin fingerprinting unlinkability, which is a big mouthful to say that they actually try to make every single Tor user look exactly the same. So what they do is they strip down WebGL. They say only a certain amount of WebGL can run, so that a site cannot determine what graphics card you have, for example. They make everyone look like they're using Windows 7 with no gamepads. They disable device sensors. All of these things are known fingerprinting vectors, right? So they actually turn off a whole bunch of APIs. But to really debug everything, if you want to find out if your code is going to work on Tor, just download Tor. You are safe to download Tor. It is not illegal. There's nothing wrong with downloading Tor, and you will have a crap ton of fun doing it. And Tor has its dev tools, right? Because it's Firefox ESR. So you have Tor dev tools. Open up your site in Tor. Open up the dev tools. Start messing around with it. See what's broken. See what console errors are being spat out, right? This is actually pretty fun stuff. Some of your code is still going to be broken in Tor, but you have to come to ThunderPlanes to learn why. Or watch ThunderPlanes. I think they'll stream it. So in summary, for this, you need to optimize for latency, make it work in Firefox ESR. The TLDR and all that other stuff is basically graceful degradation, right? Make it work without all these fancy things. So writing code for Tor actually makes your code better for everyone. There are a lot of these things you should be doing that will make your code fast and secure and work better for all users, not just Tor users. So here's the part where you get owned if you were trying to stay anonymous running your code on the dark web. We're finally to the dark web. So this is one way to think about the dark web. At the top, the surface web, the clear web, whatever we're going to call it now, you've got all the stuff you know about. The deep web portion, this is essentially all of the stuff that's connected to the web, but is like hiding behind a corporate intranet, hiding behind some access credentials, or something that actually like the clear web just can't get to on its own. And down here, you have the dark web, which is only accessible through Tor or another kind of browser like that. This is one way of looking at it. At the top, you can turn a computer on, yay. Further down, you must be really bored, and you need to use a proxy or say hi to the FBI. So remember this big, complicated network of how a user gets to a site, right? Well, let's say that you are this person down here running this site, and you want to do this anonymously. So how do we set up site.com, right? Every computer has an IP address, and if you want your computer to be accessible, you use DNS, which is a human-friendly equivalent of an IP address, right? But when you do this, you have to go to a reseller or a registrar. You get your domain name, and it always includes, your name, your contact information, your credit card number. None of this stuff is anonymous. So how do you set the site up anonymously? What you do is you set up site.onion. So onion is a Tor hidden service, okay? A Tor hidden service uses what's called a rendezvous protocol instead of DNS. So this one is pretty complex. So hopefully you just stick with it. You don't have to understand all of this. I don't understand all of it yet, especially one of the other steps, like step 6. So we've got Alice and Bob, our heroes of the dark web. They want to connect to each other anonymously so that neither one of them knows who the other one is, right? So Bob picks some introduction points in the Tor network, and he builds circuits to them. Now remember that the circuits have 3 nodes between him and this introduction point. It's not a direct connection. So the introduction point does not know who Bob is. Now, Bob advertises this hidden service, xyz.onion, at a database. This is a distributed hash table that's well known, and all Tor clients can look it up. Alice hears that this onion exists, and she requests info from that distributed hash table. And she also picks a rendezvous point somewhere in the Tor network at the same time. So she sends a message to Bob that's encrypted with Bob's public key, listing the rendezvous point, and generates a one-time secret for Bob to say that it is actually from her, that he got the message from her, right? She asks one of Bob's introduction points to send this message to Bob. Bob connects to the rendezvous point that Alice picked and provides the one-time secret that she generated. And now they both have a Tor circuit to a rendezvous point, right? They both connected to each other without anyone knowing who the other person is. This basically adds 3 more Tor relay nodes into these connections. So really, if you're running a hidden service, optimize for latency, because you now have 6 hops, right? So again, summary of optimizing for latency. Now, onion sites are actually quite easy to set up. You don't have to run a relay. You don't have to do anything fancy. If you can download Tor itself, you can run any web server, any website you're already running. You edit your Tor RC file, and then you run Tor. So on my machine, I have this simple HTTP server at port 8000, just listen, right? In my Tor RC file, I say, okay, I've got this directory on my machine. That's where I want you to store the things you need to run a hidden service. And my hidden service is listening on 8000, and I want you to publish it that it's accessible via 80, right? You run Tor, it does this stuff. It puts a hostname file and a private key file into this directory, and now you have a .onion address. That's the hostname, right? You open up Tor, you punch in that onion, and all of a sudden I'm running Thunder Plains on the dark web. It's super easy, right? And then you can see in Tor, it's got 6 hops between the Tor browser and the hidden service. It's super easy. Your onion is working. You can still get hacked and identified. You need to come to Thunder Plains if you want to learn about onion scanning and EXIF data and images and server fingerprinting and rotten onions attacks and escapades. So, why you should write code on the dark web. So this stuff is a lot of fun. I only got really into this stuff like 3 months ago, helping out the Tor uplift team at Firefox, and it really feels like the first time you got into web tech, right? And you're like, wow, this is a horizon of like undiscovered country where you could do really bad things and no one will know, or you could do really good things and no one will know, right? It's a lot of fun to get in there and just be like, I'm just gonna do whatever the heck I want. I'm gonna screw things up. But writing code for the dark web also makes your code a lot better for everyone, right? It makes your code faster, more secure, more compatible. It also makes you think. A lot of these sort of techniques for protecting privacy tell you a lot about the kind of adversaries that are trying to get your personal information, right? Makes you think about your privacy and makes you think about others' privacy. And so, like as a privacy engineer, a privacy advocate, I always say these messages about why does privacy matter? Why is it important? So there was this article on Slate that was talking about people who censor themselves just because they know they're being watched. Not because they're doing anything bad, but as soon as they know they're being watched, they change their behavior, right? So at Thunder Plains last year, I was talking to someone about Tor, and she said, I want to try Tor, but I heard it puts you on some kind of list, and I plan to travel soon. That's a chilling effect. That's exactly it. If you don't do something just because you're worried about possibly being watched, your freedom has been chilled by that. Not that you were doing anything wrong. You're not wrong to download Tor, right? But being watched makes you change your behavior. So my answer to that, I've done a lot of weird crap on Tor, and I still travel. That's no problem. So really, go download Tor, right? Like, go try it out, mess around with it, look up some hidden services. They're fun. You know, there's drugs online or whatever, and you can chase Bitcoin to try and find out where they're, you know, selling their drugs or whatever. I mean, it's crazy. It's out there, but you're not doing anything illegal when you do it, right? Set up a hidden service. Those are lots of fun. There's an article called Privacy by Design on Smashing Magazine. This is a lot of good principles about how to design your stuff to respect privacy, even if it's not on the dark web. And then even designing like personalized services with privacy in mind. So that's it. This is up at Speaker Deck, and that's it. Come to Thunder Plains if you want to learn more. That's all I got. Are we doing questions right now, or are we waiting at? Okay, questions right now. Okay, yeah. Yeah. So it's a WebSense content gateway? What is that?
It's where it actually replaces a certificate with its own.
Oh, like a man in the middle? Yeah, so, yeah. Antivirus software is like the bane of all browser developers' existence because it's essentially a man in the middle. So Tor essentially runs a SOCKS proxy on your machine, and so you connect directly to a SOCKS proxy. So as long as that proxy is not hit by this other proxy, then you can go through it. There are tools that are used, not by Tor users, obviously, that basically try to look at Tor traffic and see what it is, right? So they watch Tor encrypted traffic and try to figure out what it is. There are varying degrees of success, right? So, all right, well, there's a question way in the back. All right, everyone between us, I am so sorry. Ah! Jeez. Sorry. There we go. Oh, yes. Many, many, many things can be done on Tor. And you should try them all.
So do you think that Tor is something we should just all be using regularly, or is it only certain applications, or am I okay to use regular browser any other time?
I use Tor as basically my new incognito mode or private browsing window. So I pretty much have Tor running all the time, and if I want to do anything that I would have thought about doing in a private window, I'll do it in Tor. Unless Google's really, really bad about, they hate Tor exit nodes. So like if you actually want to do Google type stuff, that's not good, but DuckDuckGo likes them. I saw that one. Oh, yes, best one of the night. Yeah, so you can run, there's IRC clients that'll go through Tor, and I actually have run OWASP Zap through Tor, so if you're actually like scanning for vulnerabilities and things like that, you can proxy that through Tor. But of course, you're already doing this only to sites that you have permission to do this to, so why do you need to use Tor? But you can, just throwing that out there, I guess. But yeah, so I've done IRC through Tor and web through Tor, and then some scanning tools through Tor, but that's pretty much it. Let's go over to this side and back there.
When you set up a Tor onion address, it's usually a random string of numbers. How hard is it to set up a vanity Tor address?
So I actually come to Thunder Plains. So yeah, there's a tool called Scallions that you can run that will actually generate millions of hashes per second, millions of public-private key pairs, and calculate the hashes. So Facebook did this, and they wanted to get an onion address, because there is a hidden service for Facebook. A lot of people don't know that, but so they generated a ton with a prefix of Facebook, and they just happened to, they generated like 20 that they wanted to pick, and they've actually got Facebook core wwwi.onion. So they just backronymed it to Facebook core World Wide Web infrastructure, and everybody can remember that, right? But they did have to brute force, billions of hashes before they actually got to that one. And they admitted that they lucked out to get it. Did I already throw you a? Okay. Wait, is there anyone on this side of the room? Because I don't think I've neglected the dark corner over here. The dark web, dark corner. Proton VPN? Oh, cool, yeah. Oh, sweet, yeah, very cool. And then right there also. So there's a way to do it right, and there's a way to do it wrong. And you have to go to Thunder Plains or watch Thunder Plains online. How many more questions should I do, Greg? One more? All right, last one. I want to go. Is anyone in the very, very dark that like I can't even see have a question on this side? No? Okay. So yeah, the Tor network it introduces 3 hops. So when you're doing when you're coding for it, you should optimize for latency. I have used Tor as like a private window, and for most stuff, it's very passable. A lot of the Tor nodes are in very like high speed bandwidth countries already. So really, just as the internet itself has gotten faster, Tor itself has gotten a lot faster too. So yeah, it's actually very passable to use it for browsing. So if you are going to China, I absolutely recommend you use Tor. Yes. Tor is free. That's nice. So Tor is like a free version of a VPN. VPN really depends on do you trust the VPN provider. So Tor is nice in that it hides you from even the Tor relays. So yeah, I would definitely use Tor there. All right, I gotta let Josh talk. So I'll be around all evening, so come find me for more questions.
Hi, everybody. I'm Josh Mize. I work on open infrastructure for Mozilla. I'm JG Mize on the internet, GitHub, Twitter, IRC, Slack, most other sites. So I'm going to be talking about my personal Mozilla story and how I came to be working for Mozilla on open infrastructure, a few lessons learned along the way, and about why open infrastructure is so important to me. So basically, my Mozilla story starts with I tried to hire Luke. I've been a fan ever since I installed the Mozilla suite that had been recently open sourced on my Linux laptop back in '98. But I never really thought I could work for Mozilla until I was trying to hire him for this company I was working for at the time. And he told me that he had just interviewed for a position at Mozilla. They wanted some help porting MDN, that's developer.mozilla.org, over from PHP to Python. And whenever he told me that, I thought long and hard about going to work there, but I had some other things I needed to accomplish first. But later, when I had accomplished those things at that job, I went and decided to look at Mozilla as my first choice, but along the way, I actually ended up interviewing at Google for a position as a site reliability engineer. I really liked SRE as a an approach to operations as a software engineering problem. I'm not a sysadmin, and they actually take engineers who are approaching it not just to automate the operations, but automate everything about it. But as I went to, in the course of interviewing, there was several times when I asked an engineer a question about something I'd read in like a recent white paper, and they were surprised that I knew about this thing, because as far as they knew, it was still private and internal. There was kind of a culture of secrecy at the time of a lot of their core technology. And what I realized was, while there were a lot of things that I could learn working there that I could only learn there, I would only be able to actually use them there because so much of their awesome infrastructure was private and proprietary. This is very different from when I interviewed at Mozilla, because basically everything was open source. I was able to look and see not only how good some of the code was, but also how bad. I was able to see, for example, when the position I was interviewing for, they were in the middle of converting a different site, www.mozilla.org, over from PHP to Python, and I was able to see what the various people I was interviewing with were actually doing day to day. So, surprise, surprise, I got that job. I started off as a senior web developer at Mozilla, and I was able to hit the ground running. I wrote a bunch of code. For the first project was for www. The backend is called Bedrock. It was named by this guy named Fred, who really liked the Flintstones. And it's there on GitHub. You can check it out. But while I was able to hit the ground running on that, it was written in a familiar framework. It was Python and Django. There was some other things that were less transparent. There was, so for example, after I would write the code, and if you've worked on GitHub, you've submitted your pull request on your code review and click the big green button and merged it. But then when it's time to deploy, we had this internal system called Chief that was developed and maintained by our IT department. And not only was that code not on GitHub, it wasn't even our version control. Very, very shocking to me. And I couldn't actually see it. It was actually on these servers that I didn't have access to, which at all of my previous jobs, I'd always had access to everything. It was, and I was kind of surprised. So it mostly worked. I deployed the code. I got it on the site, but sometimes there were problems with that code that I couldn't access, and there would be problems where things were different from the staging site to the production site, and certainly different from what I had running on my laptop. So I filed some bugs requesting access to get to see the server logs, to see what was actually deploying the code, because to access certain parts of the site that were in this ridiculously complex Apache config that governed a lot of the behavior of the site that kind of evolved from these 3 different PHP projects and combined into one, and then we strapped some Python on top, and it was kind of nuts. There was some initial reluctance to give me access. Like when I hired on, there was the developers and there was operations, and DevOps was a thing that might be happening elsewhere, but it wasn't happening at the time. But once I convinced them, okay, I know what I'm doing. I'm not going to break the servers. Go ahead and let me see things. I was able to understand a lot more of the behavior of the site, and we were able to implement things much faster then, because we were a lot less worried about breaking things, because I could actually see what was happening. So lesson 1 was definitely get access to deployment and production systems. So if you're a developer and you are still in an organization where you don't have access to see what's actually happening, I highly recommend at least ask. File the bugs or the issue or the support. It really makes a big difference. And the people who are running the sites and running the servers, they may be a little reluctant in some cases, but it's worth getting that access. So later, I was working on some other sites, new sites that needed to be developed, and we were still using a lot of the same tools, still mainly Python and Django, but when it came time to deploy that code, we didn't have this custom-built in-house deployment systems that were deployed to various data centers. Our IT department had this new platform as a service that they had just set up, and it was this proprietary system that was kind of it started off as an open source system, but then they had some proprietary extensions, and it had some problems. This time, though, when I was filing bugs, I couldn't actually get access to the source code. It was proprietary, and it was mainly just filing bugs that had to be escalated to the vendor, who I'm not going to name here, but they basically kind of went there, and they would have some workarounds, and we would be able to get things mostly working, but there was a lot of downtime. There was a lot of times when I had trouble rolling back. Just a regular deployment might cause significant downtime. These were newer sites, so we didn't lose like Firefox downloads, but we were losing a lot of productivity, and I lost a lot of hair. Anyway, the lesson that I learned, which really just kind of reinforced, because I was a big fan of open source in the first place, but you can't fix problems with proprietary platforms, and that regardless of, sometimes you have to deploy to, you don't always have a choice of where you're deploying your code, whether it's to a client machine or whether it's to some cloud vendor that has a proprietary deployment mechanism, but you got to take into account if you ever have a choice, try to deploy something that you can see down to whatever level you need to in order to fix the problem. So later, we're needing to move not just www.mozilla.org and this other site, but several other sites. We were actually exiting out of a data center completely. At the time, we had 2 data centers, and we were consolidating down to 1. I think we're going to be expanding later, but what ended up happening was we talked. Our IT department did have a plan, but there were some issues with the plan and the way that we were going to lose a lot along the way, and we knew that our existing deployment systems weren't going to move with us. So naturally, I decided to write my own deployment system. No, I did not decide to write my own deployment system. I'd actually been down that road before, and I did not want to do that again. Instead, I was looking for existing open source deployment systems to see what was out there that we could possibly leverage. I read a lot about, I had done some stuff with containers before. Docker had come out since then, and there was getting a lot of momentum. I read a lot about Mesos, which was a really interesting scheduling platform. There was also this newer and simpler system called Fleet that CoreOS had released that was not nearly as sophisticated as Mesos, but it seemed to be able to do what we needed. And there was also this platform called Deis, which was an open source kind of Heroku clone. So if you're familiar with Heroku, it allows you to do this git push deployment workflow. You're able to do, if you refactor your app into these, what they call 12 factors, which there's a good website, 12factor.net, I think, that talks about that philosophy, you're able to deploy it. Well, we ended up, after evaluating several of the options, we went with a combination of Docker and CoreOS and Deis running on top of it. And we ended up moving a bunch of websites onto it. We started off with some smaller, lower risk websites. We didn't jump right in with www.mozilla.org, but we did end up getting several sites onto it, and then eventually we did get out of the data center and into the cloud, one of them anyway, Amazon in this case. And we got in there, and it worked pretty well. We got several. So we have several regions currently running. We got that, so we were able to handle cluster level failures and region level failures even. But we did run into some more bugs, but this time whenever I was writing more code, it wasn't just me fixing some proprietary system or some system that's only in use at Mozilla. It was able to participate in an open source ecosystem, which was really powerful. Anytime you can jump on an existing open source ecosystem, you can leverage a lot of efforts from a lot of other people that are solving a lot of similar problems to you. So it was really powerful and beneficial because we had a relatively small team and we couldn't write all of the code that we needed to deploy our systems. We needed to focus on what the actual applications we were writing. So the lesson there, use open platforms and leverage their strengths. So later, after we'd been in the cloud for a bit, we did run into some problems with we were using Fleet, which is this very simple scheduler. And a scheduler in this context is just getting your containers running on your various, it decides where to put on your cluster, like which nodes get which containers for which apps. And as we moved along, we along with the rest of the community ended up finding Kubernetes, which if you're, quick show of hands, how many people are familiar with Kubernetes? That's okay. So it's an open distributed systems platform that runs on multiple clouds and bare metal. It started off in Google. It was inspired by their internal system called Borg. It was originally called 7 of 9, actually, because it was the newer, sexier Borg. But it was also derived from another system they called Omega. That was more of a research system. But what was interesting about Kubernetes wasn't just the heritage of the engineers that had worked on these other large-scale systems, but they actually, from the very beginning, when they started working on it, they started working on it as an open platform. It was open source. It was on GitHub. They didn't put it on their own single vendor solution. They've actually they fairly quickly donated the code to this Cloud Native Computing Foundation, which is under the Linux Foundation. There's a lot of other organizations besides Google that are actively contributing code. It's one of the most active open source projects on GitHub, actually. There's and other large entities include Red Hat. CoreOS is actually a major contributor. They've got a lot of interesting. Oh, sorry. Luke. Sorry. All right, it's all dots. All right. I'll just roll with it. So Kubernetes has a lot of other things going for it besides the purely technical advantages over some of the other platforms that we evaluated. And I've learned a lot about open source software development in the way that they approach the Kubernetes community, not just Google, not just any particular vendor. But the way that they automate their GitHub with various bots, the way that they do their testing, and the way that they run all of their public meetups and their SIGs or special interest groups. It's a fairly large project. There's about, I think someone was telling me it was about 2 million lines of code, and for a 3-year-old project, that's a fairly large amount of code to have landed. They've also got a lot of good integrations. It's not just about Kubernetes. That's just one part of open infrastructure. That's just the part that we've had a lot of success with, and it integrates well with other things like Let's Encrypt. There's actually several different ecosystems that it integrates well with. The other thing that I wanted to point out, sorry, I'm just going to plug this in. There we go. Is there was kind of a cultural change that I noticed where there was this, there's a lot of, like several years ago when I was interviewing Google, they had this culture of everything is proprietary and everything is secret. And to see such not just Kubernetes, but several other really successful open source projects come out of it has been really exciting to watch. There's also been, if you're interested, there is a book on site reliability engineering that the groups have, that some of the people who worked at Google have released now, and that's actually what I do is site reliability engineering now. So in conclusion, the open infrastructure idea is not just about not being able to fix bugs. It's not just about being able to leverage open source code. there's this non-zero sum game where you can leverage, where everyone who's participating can benefit from that infrastructure at the same time. And when it's working well, it's invisible. That's kind of what the name infrastructure implies. But when it's failing, it's really good to be able to see down below into those depths that most people fear to tread. And that is all I wanted to say about that. Sorry. Any questions? Yep. Oh, do you have any of the boxes? Oh, there we go.
Do you want to throw or?
I'll throw.
Okay.
All right. Nice stuff.
So 2 questions. Hope the first one will be fast.
Mhm.
You mentioned that some of your sites you switched to Python and Django. Are they still running on that, or have you switched again since then?
No, they're still running Python and Django, and they are all on GitHub, and you can see exactly how good and how bad the code is.
And then second question, I listened to a podcast recently talking about Kubernetes, but in the realm of Google Cloud.
Mhm.
And I almost got like a sense that there was a hint of if you're not using it in Google Cloud, kind of do it at your own risk. Sounds like you did it with AWS. How was that, or did you notice any?
Yes, excellent question. So it is, I would say it's probably the it's easiest to run in the Google Cloud. They have GKE, Google Kubernetes Engine or Google Container Engine. And that's just a few clicks to get a GKE cluster running. But there are several open source projects, like there's one called KOPS, K-O-P-S, that we use to spin up our Kubernetes clusters in AWS. There's also, Microsoft has they're investing a lot into making it easy to run on Azure. And it's possible, although more difficult naturally, to run it on bare metal. I'd say that in terms of just ease of use, yes, Google frankly does have the best one from that perspective, and they also probably have a better network and several other advantages. But not everyone can move very quickly. Like there's billing reasons, there's other stuff that you need to integrate in with. So if you already have a bunch of stuff running in AWS, like we did, or in Azure or wherever, then it probably makes more sense to be able to run there. And one of the things that I really like is the ability to, and one of the things I'm hoping to do next year actually is go multi-cloud and be able to leverage both, Amazon and Google and maybe Azure or some of our own data centers. But they can all run Kubernetes, and there's also, it's work in progress, but there's a federation layer that you can actually have an API that you talk to that can actually talk to all of your different Kubernetes servers, clusters, as though they were, but from a single API. Oh. Good catch. Site reliability engineering, yeah. So SITE, yeah, site reliability engineering, SRE, yeah. And, okay. I'm gonna throw, sorry. Sure. Yeah. So we've gone through several different CI/CD pipeline integrations. CI, continuous integration, CD, continuous delivery. We've tried Circle CI, Travis, Go. There's a Go CD, I think. But what we ended up settling back on was Jenkins. So we had started off with Jenkins, and then we did several different experiments, and Jenkins got a lot better in the meantime, and so we went back to that. So we're actually using there's a bunch of Groovy code that you can write and run in your Jenkins files, and we integrate into each project a Jenkins file, and sometimes that calls into other Groovy scripts or YAML config. But basically, probably the most mature, definitely the most mature of our pipelines is for www.mozilla.org. And I can actually show you, if I have time. You know what? I don't know if this will load. Nope. All right. I will close that. Let me just describe it very briefly. So the idea is you do a git push to the master branch, and it builds a container that has the bedrock image and some other things. It runs a set of tests that can be run against the container itself without deploying it. It deploys it to a dev server. You get, a dev cluster, a dev deployment, and then it runs some integration tests. There's a set of headless tests, and there's also a set of browser tests that we run in, I think, Firefox by default for that. Then once that passes all of those integration tests, then you have a green run, and if you end up having you have an opportunity to do some manual testing if you want against the dev server. Then if you want to go to production, you do a git push to the prod branch, which then does another set of tests against a staging environment, which include not only the headless test and the Firefox test, but we also test against Chrome and several older versions of IE, because it's important that people are able to download Firefox against this site, so we have a lot of specific tests for that. And then what we do is we deploy to our staging environment, and then in one region, I think usually it's US West 2, if that works against staging, it deploys to production, then it runs the same test against the production environment. If that works, then it does to the next region, I think, is usually Frankfurt. I forget what the name of that, but it's in Frankfurt with our EU servers, and then if that works, it goes to Tokyo. Actually, I think it goes to Tokyo first, then Frankfurt, because we try to get the lowest traffic first, and then we actually get more traffic from the EU than we do from Asia or the US, it seems like. So we do this kind of rolling deployment across each of the regions and do full suite of integration tests against each one. And if you drop into #www on irc.mozilla.org, you can see that it reports as it goes to each step if a success or failure into that channel. You can also chat about developing www.mozilla.org if you're interested. Okay. Last question. All right. Oh, sorry about that. I apologize.
Is there a certain amount of risk developing open source, and if so, how do you minimize that?
Yes, there is a certain amount of risk. If you accidentally commit credentials into your open source repositories and push them up to GitHub, then you're going to have a bad time. If you don't like the idea of people being able to access your code, how can I put this? It forces you to think about what other people might think about your code as you're writing it. That's probably a good thing, because it kind of there's this experience that you have of whenever you're writing code that no one's going to ever look at, and you're going to take a bunch of shortcuts, and no one will ever know, and it's okay that it's crappy. Now, when you push your crappy code to the internet, you realize, oh, someone might see exactly how crappy of an engineer I am. I just had to learn how to live with that. But what you realize if you look, I read a lot more code than I write. I highly recommend just spending some time reading code. You're going to find out that there is some really crappy code out there that still works. It's got all these comments about how much of a hack it is. But there's also a lot of code that's really well tested, really well documented, and you can learn how to be a better developer from that. And whenever you're putting your code out there, your GitHub profile or wherever you choose to host your open source code really becomes a kind of profile, and it really allows you to take pride in your work. And this is one of the biggest transitions that we had from an infrastructure standpoint is typically our web code, our browser, and most of our code was open source. It was on GitHub or Bitbucket or wherever. But putting our infrastructure code on there has been really nice to leverage some of the same advantages and disadvantages, because whenever a site goes down and you put an issue about it, like we don't put like security issues on there, like we do have some private stuff. We don't put our credentials in our private GitHub repo, but saying, yeah, we're going to fix this, or this is broken, you just have to kind of accept that anyone who cares to look is going to see exactly how broken stuff is. All right, so, Greg?
Okay, we're gonna do another switcheroo right here. Jason, you get that mic stand too? All right, cool. While we're switching, just a reminder of our sponsors tonight. Mother's Beer back there still being slung all night long. And of course, Eagle Speak. Let's get that next hoodie out of the way here. Tom. Jesse and Skelton. Jesse, hey, all right, right on. So when we're done here, just come over. Eagle Speak will be at the booth over there. Along with Jesse, you all in this room have access to Eagle Speak at eaglespeak.net. Sign up at /Mozilla. Ready to go? All right, Greg Tatum, ladies and gentlemen.
Okay, so, that's loud. So I'm going to be talking about WebGL, which is the web graphics library, which is an API to draw in the browser. And I'm going to talk about how that's different from kind of what a normal website is and dive into kind of fun things that you can do with it. So, I'm Greg Tatum. I work on DevTools on Firefox, specifically performance and memory tooling, mostly performance lately. I'm on the social medias at Tatum Creative. And so what's a website? When you're building a website, what are you interacting with? Typically, you're writing markup and you're generating the DOM. So this is pretty typical of what you look at. So there's an H1 tag. The H1 tag might have some text in it, and there's a paragraph tag. You might have images or videos or things embedded into it. And that's pretty cool, and that's what the browser has traditionally been built around. But moving beyond the DOM, you can start to look at newer graphics libraries like WebGL, which enable a whole new class of applications that you can build for the web. And so what that looks like is instead of all this embedded markup with all the description of what you're doing, you have a single element called just a canvas, which is basically a picture embedded into your web page. And so for me, I have an art background, and so I really enjoy being able to experiment with programming interesting things and making them like very expressive and artistic. And so I'm going to dive into some examples of that. Hold on while I get this situated. So all my code which I deliver is just through a website. So you can click on it. It has a normal link that you use. And whenever it runs right in the browser. And so you can create all kinds of, for me, I like the programming approach of creating kind of things from scratch and using code to generate things. So for instance, this model right here is built from math and geometry. There's no preloaded asset that comes along. So I have different geometry rules that I use to take a box and subdivide it down and then smooth it and then extract little tendrils and then use math to light it all and make it look like it's realistic. And part of this series is about just late at night programming a whole bunch of stuff and then seeing what I can come up with to see like kind of the crazy stuff that I can make my browser do. And again, these are pixels embedded on a web page, and I'm updating them real time when I'm doing it. So this goes into my very scary live coding session. Yes. So hopefully, what we'll do So with WebGL, what you're doing is you're leveraging the graphics card. The graphics card can operate on things in parallel. And in order to do that, you have to set up some things. So I'll try to describe from a high level what that looks like. And so there are 4 things I'm going to talk about. I'm going to talk about attributes, shaders, uniforms, and varying values. So to start with, if we're going to draw something in 3 dimensions, the first thing we need is the data that we want to draw. So that's going to be our attributes. And here I have this function I wrote called generatePlane. And generatePlane in the implementation, it starts out and it creates an array, and then it has some for loops, and then does some math. And that math, what that's doing is it's defining triangles. So triangles are the basic unit that we want to operate on. And so what that looks like is I can define, here are my points, an x value, a z value, and the y is just going to be 0. So it's going to be a plane going along the x-axis and the z-axis. And what I'm going to do is I'm going to take this array I had earlier and push on individual points. And you can see, as I've defined with my little ASCII art, is I have triangle A and triangle B, and then I'm going to build points from here, here, and here, and then here, here, and here. So the first triangle is going to be those first 3, and the next one's going to be the next 3. And then I'm going to return those. So I'm going to go ahead and start with some of the coding, and I'm going to not explain what I'm doing, because why take the mystery away? So I changed it to draw lines instead. And so now I have 100 by 100, so I'm going to change this to draw 10 by 10. So this is a grid of 10 squares on each side, and I can adjust that to whatever size I want. But what I want is to keep it at 100, so I have lots of triangles I can work with. And so attributes are the things that I'm going to be operating on. I'm going to feed into a shader. So the next logical question is, well, what's a shader? You shade things is kind of the obvious answer, but it's a little bit more nuanced than that. There are 2 types of shaders. One is a vertex shader. So we've just created vertices, so we're going to be able to run a shader program that then moves our vertices. And the second shader program draws the pixels on the screen. So we've actually got 2 different shader programs. And right here, I've done a little bit of magic and have just inlined those here. And I'm using a WebGL library called Regal. Just gloss over all those details and look at the shiny code. This is the shader to move the vertices. And here, I'm passing in an attribute. So you see the word attribute there, and it's my position. So what I can do is I can say, rather than using that position, I'll use position 2, and just set it to that position, and pass that in. The reason is I can't change the attribute, so I need a new copy of it. So what I'm going to do now is change the shader just a little bit, and move that value up and down. Okay, well that's kind of fun. I can take this in here, and I can manipulate everything at once. But maybe I want to throw some other information in there. That is, right now this program is operating on 1 vertex at a time in parallel. So this is running at whatever 100 times, however many points that is, it's operating on each of those independently. So maybe I want to, I'm only looking at 1, so how do I differentiate them and work with them? Well, what I want to do is then pass in a uniform value. So this will be uniform across all of the points. And kind of the most fun uniform to do is time. So uniform, and this is GLSL, which is a different language. And I can do the position y is going to be equal to the time. So you can see that's going to start, if I refresh the page, that's going to start flying off the screen, which, okay, that's starting to be cool. But a sine function just looks like this if you graph it. It goes up and down, up and down. So if I run time through a sine function, I can start to control and work with the data that I have. So this is a grid, so maybe I want this to go faster. Maybe I don't want it to go up so much, so I'll make it a higher magnitude, so it's, here, let's go ahead and play with the values a little bit more extreme. 10, 100, you get the idea. Let's do 4, because that seems like a great number. Okay, so we're operating everything, but there's all these positions we're not doing anything with. So let's take position.x plus the time. Okay, so now each sine wave is offset by the position of the x value. So it's a little wavy, but we can make it more wavy. So I'll go ahead and start multiplying again. And I can make it more and more wavy. There's a whole bunch of waves. 109, that's probably way too many. So we kind of see that, but we're dealing with three-dimensional data, so let's add another dimension. So we'll take this, which is kind of going off the screen, but that's okay. And so I have 2 of these sine functions now that I'm working with. And the second one, I'm just going to do position.y. Or position.z, I'm sorry. So now I've got this funky shape of everything moving across. And maybe it's a little tall, so I'll do something like that. Okay, so it's all red. It's flying around. That's fine. How do we start working with the colors? So we go down to my second shader, which is, again, inlined with magic, so just ignore the magic. So this is another shader program. And by the way, these shader programs are just text, and they actually get compiled on the fly into machine code and run on your shaders, which I think is just completely crazy. And what my output is a 4-dimensional vector of RGBA, so kind of typical graphics colors. So if I add the green value there, so red and green together make yellow, I can start to control the colors with it. But again, this is the same across everything. So how do I get values down to this area? So what I'm going to do is I'm going to take each position and then take that and feed it down into the fragment shader. And so that's our 4th value, which is the varying value. So we're going to take varying, and so this is another keyword, varying. I'm going to call it a V position, or a vec3 of a V position. So we're going to make another copy of our position, which will be fed down to our next one. So I'm going to create another one here, varying V position, vec3 V position. And I keep on saving to make sure I don't type anything wrong. And then finally, I'm going to start feeding that in. So I'm going to take v position.x and hope something happens. Okay, so you can see now one side of my view is starting to get dark. Maybe a dot y for up and down. Okay, so now we can start to see a little bit of the shading happening. Hopefully it's bright enough to see. But it's a little dark, so we'll go ahead and add some magic number to it of 0.4. Okay, now we start to get a sense of shading for this. This is not like math. This is not going to simulate reality by any means at this point. But it's fun because we can start to build with these 3 dimensions and start to define something with some code. So that's the y value. What else should we do? Let's encode the x here. Okay, now we're starting to get some colors. And then, yeah, that's good enough. And then maybe we'll add some more sine functions, because I love sine functions. Why not? So we'll do another one, and then let's do, no. I'm trying to remember what each of these does. So 100. Yes! Now we're getting like some wobbly bits and things. So what I do late at night, whenever I'm tired of a long day programming, working on Firefox performance tools, I'm like, I want to play some video games. No, I'm going to go creative code and like make things fly across the screen and make some pretty colors. So this is kind of like my way of knitting and relaxing. So it's like, and then my wife will be falling asleep. I'll go like, ooh, that's fun. So that gives you a little peek into, if you've studied math at all and you are interested in programming, it can be a kind of addictive thing to start to explore maybe some math concepts. And they don't have to be crazy, because you can start with 2 dimensions or different things like that, and start with one small idea and say, I'm going to do this one thing, and then I'm going to throw a sign function at it because we like to make things fly around, and it's really fun. So if you're interested in that, I highly recommend checking out how kind of the web browser is nice, because I can have this idea, play with it, and it's a browser. So I don't have to have anyone have any special kind of hardware that goes with it. All I need to do is send it out as a website, and I can share it with anyone. And that's kind of what my process is. I'll create something and then have it as a website and share it on Twitter, and then hopefully someone else likes it. Like, I was working on it because it was fun, and I like doing the kind of creative bits. And yeah, I really enjoy it, and hopefully you all do too. And if you're interested in doing it, I recommend, if you're looking for frameworks, because I always get this question, D3 is great for like 2D stuff. 3JS is really nice for diving into some of the 3D stuff. I'm using Regal, R-E-G-L, which kind of gets out of the way and just gives me access to, does like a nicer API on top of WebGL. And I'm online, and you can follow me on all those things and chat with me, and I'm happy to point anyone in a direction if they're interested in learning more about it. So thank you so much. Okay, who wants to have a Firefox slung at them? Okay, here. Watch out. Oh. So it's cool. Okay, so with 2D data, you can do things to project it and play around with it. So you could just naively manipulate it and move it around. But phones are actually getting a lot of 3D information. The new iPhone has all kinds of sensors with it. So if you can find a way to access that information, you can actually drive that into the 3 dimensions. But it's a matter of taking something that is 2D and then finding out what it means to be 3D and how you take that extra coordinate to do it. So I'm gonna do one on this side. Anyone over here? I saw. Yeah, oh, back. Whoa! I'm really scared to throw hard back here in this. So the question was about how delivering for the web is different than native, especially around WebVR and things like that. So WebGL is a wrapper around OpenGL. So OpenGL is a graphics library that lets you do all kinds of 3D things, and you can write wonderful like C++ code to interact with that, and it's fun. I highly recommend it. Well, WebGL takes all that and makes it safe to use in the browser. So if you're looking between native and the existing tool set and the browser, you have all the benefits of using the browser whenever you're delivering your things. I would say a lot of times if you're interested in a product or having a lot of ability to create things, go where the users are, where they are creating interesting things in that space and where there's a community and be able to follow it. For me, my own value proposition is I want to share these things with people. I want to interact with people online. I'm interested in open source because I'm interested in expressing a lot of these ideas, so I can go out and easily interact with those people. I actually, getting into open source, wrote a lot of the documentation for 3JS by opening it up and reading the source code and being like, why are there no docs? So I just went and wrote the docs, and hopefully they're mildly correct. I'm hoping they're not too out of date because I haven't gone back in there in a while. But native will beat the web on raw performance power. But I don't think native will beat the web on the potential for reach, and the potential for the way you communicate with people. I think it's a safe bet to bet on the web. And over time, I think that has been validated in many ways. And I think it will continue to. And I'm going to continue. I mean, I work for Mozilla. I'm working on a browser. Like, I'm betting on the web. But I would advocate other people, too, as well. OK. I'm going to do something back. Here, we'll do right there. So I've seen a lot of really cool demos in WebGL. I'm curious, like, are there any noteworthy examples of WebGL being used in a more like production, live environment? Google Maps. Like you think like 3D, right? But really, what you're getting is access to a parallel computing machine, which is opinionated towards 3D graphics. So there's certain things built into the architecture that make it really good for doing 3D. But beyond that, you can do, I think mapping is the biggest, quickest win that we're going to get. But WebVR is a thing. So you can put on goggles and enter the web as a virtual reality experience, and it works. Like, there's links. There's a URL for things. Another example is I actually built a small video game that you can, it's like a little spaceship game, but all the levels are just a URL. So if you go to a level, you're just going to your URL, and I did that because I was interested in building a game, which is an endeavor that you lose a lot of time on, and like you never get anywhere. Your mileage may vary. But I was trying to make it a little bit quicker by developing small levels and being able to share them with people right away with a URL. So that way they could have access to it as I was kind of experimenting with ideas. Oh.
So you kind of already answered my question, but some of this would be good for game development and modeling for landscape or something like that?
Yeah, so like some of my work, I like to do it the hard way, which is writing math and geometry code to manipulate stuff. But there's still a lot of ways you can export from existing applications, and I know there's new development environments for the web being opened up that you can go in and have access to that. So.
Math sounds like a fun way to lead.
Do what?
Math sounds like a fun way to lead.
Yeah. It is interesting. We'll take one more question. And there you go.
So whenever you're doing the creative coding, how often do you start with the end in mind, and how often do you just throw numbers at it and see what happens?
I would say I 75% of the time know what I'm going to do, and 25% of the time I mess up and it's prettier than what I intended to do. That happens a lot, actually, whenever you're like, I'm going to do this, and now I have this, and then, oh, pretty. It's continually surprising, especially with different types of behavior of groups, when you have self-referential instances of things, which that makes no sense. I'm just going to pull up a visualization. If my internet works. The web's great, you should use it. Imagine you see things flying across your screen. Anyway, being able to build schooling fish, oh, there it goes, schooling fish that come across the screen, and then trying to figure out, like, okay, well, how do I build this? I need each fish to look at it, at the other one. They need a line. They need to be a certain amount away. They don't want to be too close or too far away. And then you are just programming some random algorithm, which is the Boyd's algorithm. And then you start to say, oh, it's starting to work. And then, like, how many times can I increase this? And you get this behavior that is much more than just the code you wrote. And for me, that's really addictive to be able to see, which is just like, I'll read a paper or just, like, figure out some math that I can use and like implement something and then see kind of the amazing effects that come out of it. So that's kind of a little addictive and why I keep on doing it. So thank you all for coming to the Mozilla Dev Roadshow. Thanks so much for having us. I think Mike's going to close us out now.
Greg, crushing it. Okay, few things, guys. First of all, that last Eagle Speak hoodie. Tom Rankin. Josh Willis. Still here? There he is. All right. Head over to that old Eagle Speak booth here in a bit. We do have a couple of things to give away that we normally do, right? So I know we're giving a bunch of stuff away tonight, but this is the standard stuff. So we have 3 things left. We'll have a couple of T-shirts, and then last, like we give away every month, is a license to any one of JetBrains' offerings. So if you signed in when you came in, you will have a chance to get these. So 1 second here. And, come December, when we have that app built, this is where you would get that notification on your phone. Okay, so the first 2 T-shirts that are from Telerik. We've got a couple to choose from, so you can come over and check these out here after a little bit. The first one goes to Tiffany Ford. Yeah. The second one goes to Josh Foster. JF. What? Did he leave? All right. Somebody else. 1 second here. I gotta keep the last one in mind. All right. Tim Franklin. What the? Roll. All right. You got a whole stock of these shirts too, yeah? Tim Franklin, .NET Users Group, everybody. Okay. Who's next? Jim Hodge. All right. And for the JetBrains license, we have Joe Smith. Fantastic. All right. See me after here in a little bit. I'll get you settled there. Okay. That's pretty much all we have. So for the rest of the night, you guys going to be doing VR for a little bit still? You hanging around for a little bit? No? Fantastic. So VR is going to be set up, slinging the last bits of beer back there. And then anybody interested, we are going to go out tonight. So where's Greg? Where's Greg and okay. I don't know where we're starting. We're either going to start at 417 Tap House or over at Brewco. So if you're interested, hang out. We'll kind of formulate a plan and start at one, and then maybe navigate to the other. So that is all we have. Check the meetup for the November plans for the Hack Night. So thank you all so much for coming out and making this a big turnout. See you guys.